Good morning, everyone. Thank you for joining us. I'm Steve.
And I'm Scott.
And together we are Backyard Musings, Apple Valley, California.
Science and Technology Channel.
All things science. Are you the expert?
Absolutely not.
Am I the expert?
Of nothing. So.
No, not. We're just the messengers, okay? So leave us your comments. Really interesting, fascinating subject today. Right? How do I say that, right? Astronomers using a cutting-edge adaptive optics instrument on Earth-based telescopes, and it's called the MagAO-X, have captured unprecedented images of young planets orbiting the star PDS-70, a star that is 370 light years away.
That's a bit.
Yeah, that's a bit. These infant planets are surrounded by dust rings that may form moons, the accretion disk, right? Offering a rare look into planetary evolution. We talked about that with the moon. How the moon probably was formed when Theia hit the Earth, proto-Earth, and offering a rare look into planetary evolution. This breakthrough appeared in a paper published the 16th of December 2024 in the Astronomical Journal. Would you like to know more?
Our solar system, now over 4.5 billion years old, is considered middle-aged. Any images of its earliest days are long lost to time. However, using advanced adaptive optics, astronomers at the University of Arizona, that's the crosstown rival, right?
That's right.
Have captured an unprecedented look at planets in their infancy. The team used the Magellan Adaptive Optics Extreme MagAO-X instrument to observe two young planets orbiting PDS-70. A 5 million year old star in the constellation Centaurus, located 370 light years from Earth.
So these are Earth-based telescopes, right? And we're going to see how they do it. It's probably AI too involved. The scientists' findings reveal for the first time compact rings of dust surrounding these infant planets, material that may eventually form moons, like the accretion disk we talked about. The researchers also detected dramatic changes in the planet's brightness, a sign of the system's chaotic early years. MagAO-X achieves its remarkable clarity with a rapidly shape-shifting mirror that corrects for atmospheric distortion, much like noise-canceling headphones filter out background sound.
Quote, "This is a really great breakthrough in technology," said Laird Close.
What kind of a name is that? Laird Close.
Yeah, I'm hoping we're pronouncing at least the first name. I got the last name, I think.
I mean, we think it's a for real article here, but Laird Close?
Yeah, I don't know.
Is that Comanche?
I don't know.
Huh.
A professor of astronomy at Steward Observatory in the University of Arizona College of Science.
U of A. That explains it.
Yeah. Did you put U of A on there because you didn't want me to say that?
I didn't want you to say it.
Okay, sorry. Adding that the images surpass the resolution of space telescopes, including the 2.4 meter Hubble Space Telescope and the James Webb Space Telescope, paired with a 6.5 meter Magellan Telescope at Las Campanas Observatory in Chile. The instrument works as an adaptive optics system, meaning it corrects for turbulence in the atmosphere that hampers astronomical observations. Effectively, the system eliminates the twinkle of stars, enabling the telescope to make images rivaling those from an optical space telescope.
Twinkle, twinkle, little star.
We should go over and check out our observatory here. I've told you about
I know. We need to. We definitely need to.
We have it right here in our backyard.
Maybe during like a full moon, let's go check out craters of the moon.
Yeah.
See if we can find the lander.
We got to look up when they're open. They're only open on certain days.
I would think that during full moons they'll do it so that people can see the full moons.
Yeah. They're looking at stuff all the time. So,
and this said that this surpasses the spaceborne telescopes. That's what it said. We'll let you decide.
Yeah.
Quote, "The mirror shape shifts," well, that sounds weird, "at a rate comparable to adjusting an eyeglass prescription 2,000 times per second." What? That's got to be AI, right? It's got to be.
I guess.
Close said, "Because our technology removes disturbances from the atmosphere, it's a bit like taking a 6.5 meter telescope mirror and putting it in outer space by clicking a computer mouse button." That would be great. Quote, "This level of resolution revealed features around these planets in incredible detail," he added. "To give you an idea of the resolution, picture me standing in Phoenix, where Arizona State is, right? Tempe, And you standing in Tucson, where U of A, with MagAO-X, you'd be able to see whether I'm holding up $0.25 coin or two from 125 miles away. So I wonder why you'd want to be looking at anything in Tucson. Why? Why would you want to do that?
My wife has family in Tucson.
Oh, okay. I take it back. I think Wildcats.
I don't know.
Okay.
I don't know if they are. Astronomers believe that during its infancy, our solar system might have resembled a smaller version of the PSD-70 planetary system. The star is surrounded by a giant pancake-shaped disk of gas and dust. Intriguingly, the disk is marked by a large dust-free gap, hinting at planets. Multiple massive planets act kind of like brooms or vacuum cleaners, close said. They basically scatter the dust away and clear the large gap that we observe in this great big disk of gas and dust that surrounds the star, unquote.
Have you ever watched Wall-E?
I have seen that movie. Yeah.
Remember the little mole? He's cleaning everything up. That's what that reminds me of. He goes up there and cleans all the dust. Infant planets, known as protoplanets, are very rare, and the PDS-70 planets B and C are the only such planets well known to astronomers out of 5,000 confirmed exoplanets. Developing sharper images of protoplanets and the dust around them is key to understanding how planets and their moons form, according to the research team. Although the planets in PSD-70 already contain several times the mass of Jupiter, that's big.
That is big.
They are only about 5 million years old, which means that they are still growing. Oh yeah, because the Earth is older than that. They're still growing as the planets gain mass from their birth cloud. Waterfalls of hydrogen gas fall onto them, Close explained.
When that happens, the planet glows in what astronomers call the H alpha, a wavelength of light emitted by hydrogen gas when in a certain excited state from the shock heating of the gas hitting the planet's surface. Quote, targeting that special wavelength of light allows MagAO-X to effectively limit noise and distinguish between protoplanets and their surrounding features or imaging artifacts, Close explained. To go on with a quote, we can see for the first time rings of dust surrounding the protoplanets made visible by the bright starlight reflecting off of them, added Jalen Lee.
It's Chinese.
Okay. A doctoral student in astronomy and co-author of the paper. Over the next few million years, the dust likely will collapse to form moons around each of these young planets. That's interesting.
Yeah.
Go ahead.
Thank you. MagAO-X's sharp images revealed the first observation of young planets dramatically changing in brightness. The researchers saw one of the planets, PDS-70b, fade to 1/5 its original brightness over just 3 years, while the other, PDS-70c, doubled in brightness, Close said, explaining that the rapid change in brightness at H alpha could be due to changes in the amount of hydrogen gas that is flowing onto the planets. Quote, essentially, one of the planets abruptly went on a diet while the other was feasting on hydrogen, he said. Still, scientists are not yet sure what exactly causes such dramatic changes.
Another quote here. Our team will continue to utilize MagAO-X to search for more protoplanets around the other young stars, Close said. While discovering these protoplanets is right at the edge of what is technically possible today, as technology improves, we should discover more such systems in the near future. One of our main goals is to demonstrate just how well these observations can be done with telescopes on the ground, said MagAO-X principal investigator Jared Males.
What kind of a name is that, Jared Males? Only U of A, I'm telling you.
If your comments come, please direct them at Steve, an associate astronomer at Stewart Observatory. Quote, we can always build larger telescopes on the ground than in space. True. This result shows how important it is to build the next generation of even larger telescopes and equipment with instruments like MagAO-X. So I wonder if they're not able to use some of these antennas that we have. We've talked about it.
Like the dish, you mean?
Like the dish antennas that are here. Uh-huh. And we've got them all. We got it here in the United States.
New
they're
Mexico.
In Australia.
Yes, southern
Spain.
South America. That's one of the big ones.
Yeah. So, yeah, I wonder if maybe they're outdated. I don't know.
But that's where that's different. That's apples and oranges. I mean, he's talking about a telescope with mirrors so that you can see. These dishes are collecting radio sounds.
Right. Yeah. And then transferring them into pictures.
Right. I don't know. They transfer the pictures. I just think they just collect sound.
Okay.
Yeah, do I stand correct?
If anybody works for the Jet Propulsion Laboratory in any of these deep space tracking stations, let us know. So I should probably know that because my dad worked there, but he was not a space. Yeah, he wasn't a rocket science. He was a mechanical engineer. But yeah, let us know if you know. So
I give the U of A a hard time because I, of course, graduated from Arizona State, so I'm a Sun Devil. But I hope Bishop's daughter's not watching because she goes to U of A.
Does she?
Yeah, she does.
Oh.
I hope she is not watching for obvious reasons.
Okay.
Okay. Thanks a lot. We'll talk to you later.
Don't take it personal. Take care, everyone. Thanks.